membrane right here. So here I put a bunch of potassium chloride, and this, say this is a beaker, whatever, a bunch of potassium chloride right here. Membrane is only permeable to potassium.
Okay.
What's going to make potassium go this way?
Well,
Concentration gradient,
yeah,
right?
yeah, yeah.
What would make it want to come back?
Charge.
The charge
Yeah.
of the positive or negative proteins.
So electrical gradient comes this way, chemical gradient makes it come this way. Wait, did I say it? Chemical gradient comes this way, electric come back, sorry.
Okay,
Chemical is the same thing as concentration gradient.
Yeah.
okay.
Okay. So
It's just a big word.
Yeah, because normally when we think about things equalize, it's because of concentration. But now we're throwing another factor in, well, there's a charge that attracts it.
Yeah.
So it'll reach equilibrium, but it'll be different than if it was just concentration.
Okay.
The
There's
electrical,
another pole.
yeah, the electrical gradient holds that potassium close to the membrane, but it tries to bring it back. But the
Yeah.
chemical, the flow of everything brings it out.
Yeah, so exactly. So what's ultimately going to happen is the potassium's going to go in circles.
Yeah.
And the same amount of potassium flowing in is going to flow out, and they're going to go like this.
So, I mean, when they were talking about the resting membrane, I mean, resting
Membrane potential.
It's the same thing. That's exactly what it is, because potassium goes out, but it comes back in anyways.
Same thing, yeah. Because there's the leak channels that are always open, right?
Right.
Like sodium and a lot of other things can't just leave whenever it wants. Potassium is like the main thing that can determines like this is where the membrane potential is, -70. Because a certain amount of potassium leaves and comes in and it settles right around there.
And does the sodium potassium pump keep it pretty, like that's what keeps it pretty level?
That contributes to it because that's what pumps in the potassium, right?
Okay.
So what would happen, say there's 3 potassium leak channels, what if I closed one? Would the charge of the cell go more positive or go more negative?
It'd go more negative.
Why do you think more negative?
It's because your potassium, your positive charge is leaving, and it's not as much as coming back in. So it's depolarizing. Or, what is it? Hyperpolarizing? Hyperpolarizing.
And what did you think? Why did you say positive?
Because the leak channels let the potassium go out because of the concentration gradient. So if there was one that was closed, then less potassium would be going out. So there'd be more of a positive.
Oh,
So it is more
effect.
positive. Yeah, you see what you're saying?
Yeah,
Now it makes sense.
okay.
Yeah. So what if you open up a bunch more leak channels? What's going to happen to the membrane potential?
Change
faster.
And it's going to go down, right? Change way faster. Okay.
Okay.
You guys want to do action potentials or what do you?
Sure.
Yeah, that's fine. Pretty big part of the test. It's kind of like
Yeah.
Really,
this will be.
it's huge.
Yeah, and like later on, throughout the rest of the course, we talk about action potential because it's pretty much how everything works.
Okay, let's do that then.
So let's do that. Kind of complicated, but once you kind of get the steps down, it's not too bad.
Let's see if we can explain it to you.
Yeah.
Step at a time. Does that sound good? You
Yeah.
ready?
Yeah.
Go for it.
Okay, so you've got all kinds of channels on the outside. You've got the sodium potassium pump. And
Yeah, your leak
yeah,
channels.
2 and 3. Then you have potassium leak channels.
3, yeah, that's your 3. Okay. I thought that looked like a 2, but.
It does look like it too.
Okay. Got your leak channels for sodium and potassium.
Well, are they leak channels or are they?
There's leak channels for sodium, but there's like few.
It's a few.
Okay.
Yeah, this is like the main one. Potassium leak channels.
Okay,
What are they?
and there's voltage gated channels for sodium, and the inactivation gate is open. Right?
Yeah. Which is that this one?
Yeah, yeah.
I was getting that confused. Okay.
Okay, so those are the 3 main ones, right?
Yeah, there is kind of one more type that.
Potassium,
But
gates.
Ligands?
So there's ligand. Yeah, that's the main one.
Oh, okay.
Right here.
That's the one that pretty much is stimulated by a neuron or whatever that comes in. Yeah, comes in and says the stimulus,
So what happens? This is released, and then what?
and then the gates. Well, if it's strong enough, it'll open the ligand gates. It releases the acetylcholine.
There you go, that's the key, if it's strong enough.
So yeah, those guys bind right here, open up these gates. And what are they specific for? What ion?
Sodium.
Oh, so
Sodium.
you leak it.
So what is it that binds to it that opens it?
A neurotransmitter.
Okay, so That's all I need to know.
It can be, like you said, it could be acetylcholine is one of them.
Okay,
There's others too.
alright.
Generally just a neurotransmitter.
Yeah, like the neurons that bind, like stimulate your muscles, it's all acetylcholine.